in this video, we'll solve oblique triangles using sine law. Before we do that, let's recall how to label a oblique triangle. Let's say this angle is ABC, all right? And we're going to label the opposite sides using the same letters of the angles. So opposite angle A is side A, opposite angle B is side B, and opposite angle C is side C. Now let's give this triangle some information. Let's say angle A is 45 degrees, side A is 15 centimeters, side C is 18 centimeters, and we will figure out what is the measurement of angle C. All right, so let's see what case do we have here. We have side A that we know, side C, and angle A. So side angle is the case that we have here, so we know for sure we can use sine law. Now let's create the opposite pairs. Angle A and side A is given to me, so there goes one of the ratios, and the other one, I have side C and I'm required to figure out what is angle C, so this is my other ratio. Let's write them down. So I have, since I'm solving for angle now, I'm going to try to keep the unknown, not try, but we're going to keep the unknown in the numerator. So sine of angle C over C equals sine of angle A divided by side A. Let's plot the information that we have from the triangle. Angle C is our unknown, side C is 18 centimeters, angle A is 45 degrees, whereas side A is 15 centimeters. To isolate angle C, we're going to multiply both sides by 18. There we go. Sine of C equals 18 sine of 45 degrees divided by 15. By plotting that into our calculator, we're going to figure out that sine of C equals 0.8485 as we round to the fourth decimal place. Now, since we're solving for angle, we will use the inverse of sine. So angle C equals inverse of 0.8485. Put that into your calculator by using the inverse, the shift button or the second function, and there you go. Angle C rounded to the nearest degree is 58 degrees. All right. Now let's look for another triangle. Let's say we have this triangle, and we're going to label that triangle LMN instead. LMN. Okay, let's do the labeling before we continue. So this is side L, this is side N, and this is side M lowercase, right? Let me erase that to make it look a little bit better. So side M here. All right, let's provide some information. Let's say that angle N is 65 degrees. All right, angle M 38 degrees, and side N is 20 centimeters, and we're going to find out what is the side L. Okay, let's analyze here what kind of information and what case do we have here. I have an angle, another angle, and one side. So the case side, angle, angle. All right, so I know I can use sine law. Let's create the pair now. The given pair, opposite pair, is side N and angle N. Now I'm required to find side L. I don't have information yet for angle L. So my first step will be figuring out what is angle L. Using the triangle's property, we know that angle L is 180 degrees minus 38 degrees minus 65 degrees, right? Because the sum of inner angles of a triangle adds up to 180 degrees, from where angle L equals to 77 degrees. All right, so now I can create this other pair here, opposite pair, to create the ratio. Now, since I'm solving for sine, it will be better if I use the ratio L over sine of L. So we have the sides on the numerator. And the other given pair we said is n over sine of angle n. Let's plot the information in. L is our variable. Side of angle L, as we figured out, is 77 degrees. N is given to us 20 centimeters, and angle N is 65 degrees. Multiplying both sides by sine of 77 in order to isolate L, and there we go. L equals 20 multiplying sine of 77 degrees divided by sine of 65 degrees. As we put that into our calculator, we figure out that side L is approximately 22 centimeters as we round to the nearest number. Okay, these were the two cases when we use sine law to solve oblique triangles.